China didn't redirect a river. They buried 612 kilometers underground through solid mountain rock. $12 billion and a water crisis so bad it threatened to collapse an entire province's power grid. The province at the center of this is Yunnan, China's southwest corner. Ancient rivers, deep gorges, mountain ranges so steep they look like walls. It borders Myanmar, Laos, and Vietnam. Most people outside China couldn't find it on a map. But for China's energy grid, it is irreplaceable. Here's why. Yunnan gets the majority of its electricity from hydropower, historically over 70 to 8% of its total generation. The province doesn't just power itself, it exports electricity to neighboring provinces and to China's industrial southeast. Factories, cities, millions of homes. Take Yunnan's water away, and you don't just have a thirsty province. You have energy instability rippling across one of the most economically active regions on Earth. And that's exactly what started happening. Drought cycles began intensifying in the 2000s. The plateau lakes that once defined Yunnan's landscape, Lake Dianqi, Lake Qilu, Lake Fuxian, started shrinking. Some dropped to critically low levels. Farmers who had worked the same land for generations began abandoning their fields. The soil was cracking. 3 of Yunnan's most vital lakes were suffocating. Lake Dianqi, the largest, and one that supplies drinking water to the provincial capital Kunming, home to roughly 6 to 7 million people in the municipality, lost so much volume that algal blooms choked the surface, and the government began emergency water rationing. A thirsty energy province means unstable power. And unstable power in Yunnan sends shockwaves all the way to the coast. China had to act. China builds dams like other countries build highways. The Three Gorges Dam, the world's largest power station, is Chinese. So are dozens of other massive hydroelectric projects across Asia. So why didn't they just dam the rivers and redirect the water? Because this time, that answer would have been catastrophic. The rivers feeding Yunnan's water crisis aren't isolated streams. They are headwaters, the very beginnings of some of the world's most important river systems. The Jinsha River, which flows through the region, is the headstream of the Yangtze, the river that drains one of the most densely populated areas on Earth and feeds hundreds of millions of people downstream. Dam that, and you risk serious consequences downstream. The Jinsha feeds into one of the most water-dependent river systems on Earth. Damming it at scale would trigger ecological damage, diplomatic pressure from downstream neighbors who depend on the same water flows, and complications China has worked hard to avoid. And then there's the terrain. The Hengduan Mountains, the range that dominates this part of Yunnan, don't just sit in one watershed. They cross 4 major river systems simultaneously: the Yangtze, the Mekong, the Salween, and the Red River. No single dam resolves that. You'd need a network of dams so large and disruptive that the cure would be worse than the disease. There was only one solution that worked with the landscape instead of against it: go underground. Build a tunnel system so long, deep, and precisely engineered that it moves water from where it floods to where it's dying, without rerouting rivers on the surface. Designed to minimize displacement and to avoid the cross-border entanglements that surface dams would have triggered, China first sketched this idea in the 1950s. For 70 years, the technology to execute it didn't exist. By the 2010s, drought cycles were worsening. The political will was there. The engineering finally caught up. China made the call. Move the river underground. Let's talk about what 664 kilometers of tunnel actually means, because the numbers alone don't capture it. Start with the rock. Over 90% of the entire route passes through solid Hengduan mountain rock, according to project engineering reports. Not soft sediment or manageable limestone. This is some of the most geologically complex terrain on the planet, ancient, dense, and extraordinarily abrasive. The machines used to bore through it, massive tunnel boring machines with rotating steel cutter heads, were eating through their own blades at a rate that stunned even the engineers. Crews had to descend into dangerously cramped conditions deep inside the mountain to swap out multi-ton cutting heads before the rock stress caused a cave-in. Now, scale that across 664 kilometers, 35 counties and mountain ranges that tower above you while you're working hundreds of meters below. The main tunnel sections are enormous, wide enough to accommodate vehicle access for maintenance. The water pressure inside requires heavy-duty sealing and pressure engineering at a level most infrastructure never demands. Every joint, every seal, every valve had to be built for forces that operate at the extreme end of civil engineering. And here's the underground chamber that stops engineers cold when they first see the specs. China built what project documents describe as one of the largest underground pump caverns in Asia, carved entirely from solid rock deep inside a mountain. The space is so vast that the United States Capitol building could fit inside it. This is where the pump array is housed, a system powerful enough to force millions of gallons of water upward through mountain terrain, hour after hour, day after day, without interruption. Think about that for a moment. You're underground, inside a mountain, in a room the size of a national landmark, watching machines push water uphill through rock at a scale that has no precedent in this part of the world. But the engineers had one more problem to solve, and it's one that haunts every infrastructure project in this region: earthquakes. The Hengduan Mountains are seismically active. The ground moves, and when you've built a 664-kilometer water system through solid rock, the ground moves is the last thing you want to hear. The solution was elegant. The entire tunnel system was designed with seismic joints and flexible connectors built in throughout, giving the tunnel the ability to bend rather than crack when the earth shifts. The system doesn't resist earthquakes, it moves with them. Decades of planning and engineering ambition produce something that isn't just an infrastructure project. It's a piece of underground architecture built for the century ahead. When the system reaches full operation, it will move 3.4 billion cubic meters of water every year. That's roughly 1.4 million Olympic swimming pools of water, redirected annually from areas of surplus to areas of critical need. Here's where it goes. Of the 3.4 billion cubic meters, 672 million cubic meters are allocated specifically to restore plateau lake ecosystems. Lake Dianqi, the one that was slowly suffocating as Kunming's lifeline, is among the primary recipients, along with lakes Qilu and Fuxian. Water quality is recovering. Ecosystems that had been slowly dying are stabilizing. These lakes are being refilled not just for drinking water, but to restore the agricultural and ecological systems that depend on them. And then there's the farmland. Over 500 million cubic meters of the annual flow is dedicated to agricultural irrigation land that had been parched and partially abandoned during the worst drought years. Farmers who walked away from their fields are returning. The soil that was cracking is being irrigated again. More than 11 million people across 35 counties in Yunnan are seeing their relationship with water change: more reliable supply, more stable agriculture, more consistent energy production. And here's the detail that tells you the most about where China is heading with its infrastructure. No large crews and manual monitoring. Officials describe extensive sensor networks and automated control systems throughout the tunnel, with AI-assisted optimization managing flow rates, pressure, and pump output in real time. China isn't just building large infrastructure, it's building infrastructure designed to operate itself. And for a province that powers an entire region, this goes beyond water. It's a climate insurance policy. As drought cycles worsen globally, Yunnan's ability to generate power and grow food no longer depends solely on rainfall. It depends on engineering. Quick pause here. If you're finding this kind of deep dive valuable, it genuinely helps to know. These documentaries take a lot of hours to research and put together. If you want to support the channel and help keep this kind of content coming, there's a link in the description and in the pinned comment where you can make a small donation, whatever feels right. No pressure at all. Now, back to the story, because this is where it gets really interesting. Here's what most coverage of this project completely misses. The Central Yunnan Water Diversion Project, 664 kilometers, $12 billion. The world's longest underground water system is not China's biggest water project. It's not even close. It is one component of a water security doctrine that China has been executing quietly for decades. A doctrine built on a simple, brutal insight. If your water is in the wrong place, you don't wait for nature to fix it. You move the water. The South-North Water Diversion Project, already partially operational, is the one that rewrites the scale conversation entirely. When fully complete, it will move 44.8 billion cubic meters of water per year across 3 separate routes, spanning a combined 4,350 kilometers, connecting China's water-rich south to its water-starved north. That's enough water to fill 18 million Olympic swimming pools every single year. 3 separate routes, decades of construction, a price tag that makes the Yunnan project look modest. China is not building individual water solutions. It is systematically re-engineering its entire water geography, redirecting rivers, filling lakes, resurrecting farmland, and insulating its economy from a climate future that every scientist on Earth agrees is getting less predictable. Which brings us to the question this project was always going to raise. Water stress is not a Chinese problem. The Middle East, North Africa, American Southwest, large parts of India and sub-Saharan Africa, according to UN and World Resources Institute estimates, somewhere between 1 and 2 billion people already live under serious water stress. Climate projections put many more at risk over the coming decades. Every one of those regions is going to need an answer. And the answer China is demonstrating is expensive, technically extraordinary, and requires a level of long-term institutional planning that most governments struggle to sustain across decades. So here's the question this project leaves open and worth sitting with. Is China's approach to water security the blueprint for how every climate-stressed nation survives the coming century? Or is it only possible because of the specific political system behind it, one that can commit to a 70-year plan, displace communities when necessary, mobilize state resources at a scale no market economy can match, and execute without electoral interruption? Because if the answer is the second one, if this level of infrastructure is only achievable under that system, then the rest of the world has a much bigger problem than water. And China has a 70-year head start. If you made it this far, thank you. Genuinely. Videos like this take dozens of hours to research, write, and produce. If you enjoy this kind of content and want to help the channel keep making it, you can make a small donation through the first link in the description or the pinned comment. There's no subscription, no obligation, just a direct way to say you want more of this. Every contribution makes a real difference. And while you're thinking about that question, whether this kind of infrastructure is only possible under one specific kind of system, here's something that's going to make it even harder to answer. China just built 157 kilometers of highway, no workers, no human crews on site, just machines and sensors doing what used to take thousands of people. Same country, same ambition, completely different kind of project, and it raises the exact same question this video just left you with. That story is already up. It's linked right there on screen and in the description below.